Okay, YouTube, in this video we're going to be discussing the concept of recursion when it comes to defining sequences. And this is kind of a confusing idea for a lot of people, but we sometimes define sequences recursively is what we call it, okay? And to recur is to kind of like reoccur, is to happen again and again and again and again, okay? So when we talk about recursive sequences, I can give you an example right here. This is the Fibonacci sequence, and you've maybe heard of the Fibonacci sequence, but the way it works is this way. We say it's a sequence of numbers that goes on forever and ever and ever, this infinite sequence. Starting at its first term here, we say the first term is 1, second term is 1. Third term, however, we say this is A1, we say A2. Its third term, however, we could say, look at this, we say it's 2. It's really the sum of the previous two terms to get this term right here. So the way this sequence works is the next term here, we say A4. A4 is actually equal to 3, but we get this because we add up the two terms prior to it. And so you could see how this next term is always the sum of the previous two terms. The idea here is this: in order to get the next term, you'll always have to reuse some of the terms that are actually in its own sequence. So you have to use the sequence again in itself to get the next term, which is the idea here. So what I'm going to do is this: I'm going to talk about how we define things recursively and how we kind of express them, but kind of the rules that follow. So this Fibonacci sequence that we just looked at here, and you'll notice that I call this A1 up here. Forgive me. We actually start the Fibonacci sequence at term 0, and we say the 0th term is 1. Okay, so the first term is 1. But essentially, we say the Fibonacci sequence can be expressed this way. Now, this is very interesting. When you define things recursively, the first thing that has to happen is this: must have some given terms. So some given terms in the sequence. We just need to know some to begin with. And so the first two terms we were told are the 0th and first term. We were told that the first two terms are 1 and 1. So now, knowing the 0th term and the first term, it says to get the kth term, what we're going to do is we're going to take ak minus 2 plus ak minus 1. And I want to kind of point this out where k is greater than or equal to 2. Let's say a was exactly 2, or k is exactly 2 here. Then this would say that ak, which is a2 in this case, would be ak minus 2, which in this case, if k is 2, we're saying a2 minus 2, plus ak minus 1, which in this case, k is 2. So this really is saying this: a2 would then have to be equal to a0 plus a1, which in other words means, hey, add up the 0th term and the first term to get the second term, so we get this 2. So again, this rule would follow again. What if we said a3, and I want to go find a3? In this case, we're saying that our k value is equal to 3, but you'll notice in this case we get a3 minus 2 plus a3 minus 1, which is really then our third term is equal to looks like our first term plus our second term. So this is always going to happen. In general, we could say that given some ak, let's put it this way, we'd say that ak minus 1, if I were to write some sequence out, would be the term right before it, and ak minus 2 would be the term right before it, and this would go on backwards and backwards, and we say ak plus 1 would be the term after the kth term, and we say all the way out to, an. But essentially, when you're seeing these ak plus 1 and k minus 1, k minus 2, we're saying it is this many terms before or after the kth term. So you'll notice here that a2 is always a1 plus a0, or a3 is a2 plus a1, or a4 is a3 plus a2. The idea is that we're going to have to use terms of the sequence to get new terms in the sequence, okay? So we're going to write out the first 5 terms of these recursively defined sequences and talk about kind of what these are saying. But let's start with this. We are given the fact that the first term in this sequence is 6. So now what we're saying is this: to find the ak plus 1th term, you have to take the ak term plus 1. So the thing that's important to recognize here is this: it's like saying to find the term after the kth term, you have to take the kth term and add 1 to it. And so what is my question here? What is the kth term to the k plus 1th term? Where is it in the sequence? And we know that in the sequence, the kth term is the term right before the k plus 1th term, okay, in this sequence. So really what this is saying is, to get every next term here, what you need to do is you need to take the kth term and add 1 to it. So in other words, we're going to take the 6 and we're going to add 1 to it, and we get 7. Now, just to demonstrate this for you, this is not something I have to do, but we said we just found the second term, and we say if this is a2, and a2 really is this ak plus 1 thing that we're trying to find right here, then we would say in this case, k would have to equal 1 because if k plus 1 is equal to 2, then k is 1. But we'd say ak plus 1 is equal to ak plus 1. Remember this. So we'd say that this is a1 plus 1 is equal to ak, which is a1 plus 1. In other words, to get the a2 term, you take a1 plus 1. In other words, to be very quick about this, this rule basically just says take the term before the k plus 1 term and add 1 to it. So we can say the next one is 8, the next one is 9, add 1 to 9, you get 10, so on and so forth. Okay. So now this rule right here, we say given the 0th term. So in this case, we'll call this the 0th term right here. A0 we say is 1, and we say A1 is 3. So we say we have our first term and our 0th term. This says to get the kth term, you take the k minus 2th term plus the k minus 1th term. You know, so like for instance, if I'm after the second term here, I want A2. I say, well then A2, which is AK. If k is 2, then I would get A2 minus 2 plus A2 minus 1. In other words, this would simplify out to A0 plus A1. But to be quicker about this, this is really just saying take the two terms before the kth term and add them together. So if I want the second term, we're going to add our first and second, or 0th and first term together, we get 4. And to get my third term, this would say take the 4 and the 3 and add those together, you get 7. And to get the fourth term, we would take the 4 and the 7 and add them together, you get 11. And then 11 and 7 would give us 18, would be our last term in this 1, 2, 3, 4, 5. I only needed the first 5 terms. So we started the 0th. So I guess we did need to go out to 18. But that is how you evaluate recursively defined sequences. Cheers.